Hello everyone, it's Dr. Barden here. Today I'm going to be talking about the upcoming project for my electronic music production course. It is going to be a little more complex than what we've done before, so I'm wanting to kind of walk everyone through the core aspects of it. We're essentially combining subtractive synthesis, control signals, routing, formatting, abstractions, all that kind of stuff into a single project, and your final goal is to turn this into a usable instrument that you could give anyone. So we're going to be starting and basically putting together the core of the synthesizer here in this video, and then you will develop and change it to make a unique sound for you and what you like. The core of this code comes from our course textbook, and I'm just bringing this up here. This is the book for anyone watching it, so I'm utilizing some of their work for a theremin patch as the base for this, but for anyone who is wanting to get into Max and this kind of processing things like that, this is definitely a resource worth getting. There is a English version. Just when I pulled up the website, it went to the Italian one, but it's the Electronic Music and Sound Design Theory and Practice with Max 8, and there's 3 different volumes, but this is not like a sponsored anything here. I just, don't sue me for using the code kind of a thing, but I legitimately recommend it. I, have had this book since before I started teaching the courses, and you can get the more and more volumes as you start doing specific things, or if you want to just go through it all and get more advanced as you go, there's definitely worth a look at. The resources are really good, really high quality, and it's a great book for that. Okay, so I mentioned we're going to be making a virtual theremin, and for anyone who doesn't know, I'm not going to read through the whole article page on it, but it was made in the 1920s by Leon Theremin, a Russian musician and engineer there. You can read up about them as well. I'm not going to dive into it all too much, but short version is it's one of the earliest electronic instruments, and it utilizes these 2 antennas and emitting radio waves in order for you to play it without actually physically touching anything. So as you move your hand around these antennas, the round one controls the volume and the straight one controls the pitch. As you're moving them in these fields, essentially it's detecting the interference from the placement of your hand, and that's what's generating the control signals for the synthesizer inside the box. That's, again, a very, very short breakdown of all of this. You could read some more general info, find out more about it on your own. That's not going to be part of this video. What is I'm going to play just a real quick example of a small sound bit, so you know the kind of sound that we're looking for. So it's got kind of this mellow tone to it, very saw wave. Otherwise, outside that mellowness, with some filter, and it's glissing between all of the notes. So because you're freely moving your hand through here. I was just thinking it would be him playing it. So as you're just moving your hand, again, to control pitch and volume, there's no distinct keys on the instrument like a piano, so you can't just play one note and immediately jump up the same distance. You have to move your hand around. In order to do it. So we have to take that into account when we are making our synthesizer. Again, there's a lot of good resources online to check it out. We're not going to deep dive into it, but definitely check out some theremin music. All right, so I've got Max pulled up here. We're going to just get that out of the way, make a new patch. And again, I'm walking you through the core of making the theremin, and then I'm going to talk about what goes into the actual project for the class at the end of the video here. So Again, this is based off of the one from the textbook. I made a few very small edits, nothing crazy, mainly it's just some formatting stuff to make it work for a video. So let's just dive in. I want to be able to control everything with the K slider right here. That way we can kind of see what's happening on our patch. We can enter in the pitches. You could, if you wanted to connect MIDI controllers to this as well, but this will give us all the control we need for what we're doing. So we're going to make the pitch, first of all, but we need to go from the MIDI output of the K slider to a frequency for our synthesizer. So MIDI to frequency object coming out of that first inlet. We'll have that there. And then I mentioned in the video before, we're going to make a sawtooth object right here for outputting the sound. So I'm starting again just with the core synthesizer and output, and then I'll be building in the stuff that determines the vibrato and the glissando and things like that. So this is getting us our note, and then we need to make the envelope for it, which we can actually get out of this second outlet of the K slider. So the velocity is effectively the volume of the MIDI data. I won't, again, deep dive into it, but that's how we're going to think about it as the volume. We just have to convert it from MIDI stuff into a platform that we can actually use. So to do that, we're going to start up with the scale object. And again, we're going from MIDI data to amplitude envelopes, because we're going to control all the amplitude, but there's an intermediate step of converting it to decibels in between that. So because we're using MIDI data, we normally have 0 to 127, but the theremin is always outputting sound. So having the velocity of 0 means there's no pitch. So we're going to actually start with 1. So again, we have the input low and high value. That's our old range that we're getting from the K slider, and the new range in decibels, we'll start with negative 25 decibels and 0 decibels as the output. So I'll just connect this up, and it will output a range in decibels instead. So the reason we went to a decibel range here is because we have a very handy object, dB to A, decibels to amplitude, and it will convert that into a linear scale that we can just use with the line object that we have made for other amplitude envelopes as well. So we just have to make our line tilde right there, and we just have to tell it, again, what value to go to and how long to take to get there. The easiest way to do that is with a message. So I don't think I've talked about this in my courses before, so I'm going to break it down now. The very first thing we're going to type in this message box is a variable, and that is just $1. And this is effectively just a placeholder in the message. And you can think of it as whatever the first value that gets sent into this message, we're going to fill it into whatever $1 is and pass it along. So if I type that space 500, and we're just going to connect this up, we're just going to connect this up. There we are. What's happening is we're getting the velocity out of the keyboard slider. So I'll get a fairly high value up here. So you see it's coming out as MIDI value 101. We're converting that to negative 5.6 dB, which will go to that linear value 0.55. And then our message going out is saying that 0.55 space 100. So it's taking the value coming from the dB to A and just putting it in here. If I got a really low value, now I've got 0.09 over 500. So we have that right there, and then we can just, like before, combine this It helps if I unlock the patch. With our sawtooth output, we can, I'm going to do it like this for the sake of lining up. We can just have this go to a volume control. And an output. And it helps if I can not hit my caps lock. And also spell easy DAC right. There we go. So I've got that right here. I'll connect it up. And we'll also start it here so I don't start the audio in my cheat sheet on the other screen. Here I'll just start the audio just in this window. So this is the basis of how we can get audio from the K slider into what we're doing. And if we turn this on and up, you'll see that we're getting there, but we aren't quite there yet. So we've got the basic sound, but it's not quite as mellow as we want it to be. We're gonna there's a lot of harshness and noise, particularly in the upper register. Get a little bit of buzzing almost. We want to get some of that out, and we don't have the glissando yet. We're still just getting distinct pitches. So that's what we're going to focus on next. So what we can do is take the MIDI note and we can basically turn that into a frequency envelope. Is kind of one way to think about it, where we can set up that glissando to and from the pitches and use that to create the sawtooth output. So that's what we're going to do. We're going to be adding a bunch of stuff to and from in the middle part here. So that's what we're going to do. So I'm going to disconnect the MIDI to frequency here, and we're going to add a bunch of stuff in between. So in order to set up the glissando, we need to know what the first note, the one that that one that was previously being played is, and the new note that we are moving to. We need to have both of those pieces of information, so that way we can calculate how far the glissando has to move and how fast it is to get there for the effect that we're looking for. And to do that, there's a very handy object called T for trigger, and whenever it gets an input, it will output a specific set of values in a specific order. I'm not going to deep dive into the help patch now, but it's definitely worth checking out. But you can give it as arguments either formants or constants. The formant is just saying what data type that you're going to send out. Symbol, numbers, floats, bangs, toggle, whatever things like that you want to have output, you can send that there. And then a constant, you could say whenever a trigger comes in, we're going to output, 30 or the same message every time. You can give it a constant value. We're not going to do that, though, because we need a few things. We need the MIDI value, and we're going to need that in a few places. That's just going to be an integer, so we're going to type in I, and we're going to need that in 3 places. In order to generate the frequency with that MIDI to frequency object down the line, we need to be able to determine the current note and the previous note that was played. And then we also need to send a bang in order to trigger all of the math to happen. So that's what we're going to need right there. I'm going to connect that up, and the first outlet is going to go into the MIDI to frequency. I do just want to point out that the order that you type these data types or constants in is going to be opposite what we have here. So if you hang over there, it's going to be output order 1, which is the bang. And then the integer, integer, integer. So it outputs them right to left, which is a little bit different than a lot of stuff going left to right, but just double check. It'll tell you if you just hover over the object outlets what each one is, but remember it's the last one first, and it works its way over. So I just want to point that out. That'll trip up a lot of people in my experience. So normally I wouldn't stick in a lot of this monitoring stuff for my my final version, but I'm going to put in multiple integer boxes as we go, partly because that's how it was done in the textbook example, and then partly because as you are developing your customized version of this, it's handy to have that data monitoring just to see what's going on, and similar logic for just, teachery stuff. So I'm just going to make that a little bit bigger for space, and we're going to work our way down the line. So I'm going to make a few integer boxes. So we're going to need them. So this first one, this is just going to tell us what our current note is. Whenever we click a MIDI note, it outputs it right there. So that's what the current note is. And we need to be able to determine what the previous note was. So we're currently on 53. If we jump to 60, we need to remember that we were on 53, so that way we can do the glissando from 53 to 60. And the way we can do that is with the object int, integers, stores an integer value. I know a few people in my classes have used this. We could also potentially save some of this data in a message box, but this is much harder to accidentally overwrite, and we're essentially hard coding that whatever number we type here is going to just output whenever it receives a message in that first inlet. Bang outputs value, and we can save a value here is what I'm getting at. So I'm just going to default to 60 middle C to start with, but that's going to be changing very quickly. So every time we get a bang sent to this object, which is our last inlet, we are going to output the number that is stored right here. And then if we just connect this to the cold inlet over here, anything coming in that will set the value without an output. So the reason we're doing it in this order is so we trigger the stored value, and then afterwards we update it with the new note. And then it's just saved there until we bang that output, update it to another new note, and we keep going. So just to see that in practice, if we click down here, we got current note 48, last one was 60, now 48 and 53, 53 and 55, 55 and 72, 55 and 38. So we have the current pitch and the previous pitch, and I'll label some of this right at the very end of everything, but we have the components that we need for math. So what we need to be able to tell is how far we have moved from the previous note to the current note. And the easiest way to do that is just to find out the difference between the two values. So if we just make a subtract object, there it is. Right here, we can just pull those values right in here and do a little bit of quick math. So this will update the values for our math, and we can see it right here. So if we click up here, you can see we moved 22 semitones versus 2. We moved down -1. That's going to be important in the next step. Up 11, down 24. We can determine how far we are moving, but the issue is, so we just need to figure out the pure distance value, because we also need to determine a time with this. We need to determine, again, how far the glissando is moving and how fast it takes to get there. We can't have the speed it takes to glissando be negative, because we haven't invented time travel yet. So we have to have a positive positive value here coming out of this subtraction box. So we can just add the ABS value, calculates an absolute value. So whatever comes into here, it's going to always be positive. So again, negative 5, it has just an absolute, its value is 5 away from 0. It just happened to be negative. So we're removing any kind of directionality from the value, and we're just getting the main output. So again, if I go here, negative 15, it helps if I add in the integer. So we're starting at 53. If I hop to 60, we get 7. If I go back down, negative 7, but then we stay positive 7. So we've, in either direction, just moved 7 semitones. Now we have to scale this up, so that way, as we move further, the glissando is able to take longer to do. And that is where I'm a little unsure on the math used by the textbook authors, but it makes an effect that works. So I'm not going to question it too much, just because I'm not sure why they pick a value of 20 here to convert. They say in the comments it converts it to milliseconds. I'm just not sure how that is going right to milliseconds. If we're going from semitone to that labeling seems a little weird. But again, I'm not here to judge, because it makes a cool effect. But effectively what we're doing is scaling up the distance by a factor of 20, just multiply 20, and this will tell us how many milliseconds it will be in our frequency envelope for that sweep. So that's what we need just right now. So I'm actually going to move this over to the next column here, and we're going to create our frequency envelope. Again, we have a line object controlling the amplitude. Now we're going to have a line object controlling the frequency. So to do that, let's make a line tilde. And we can do a whole bunch of work in order to get the values we have here into line tilde. So the reason I've set it up this way is we have the frequency we want to achieve and an amount of time it will take to get there. So we can just combine this into a list like we have over here, and bada bing, bada boom. Bob's your uncle, whatever you want to say. We've got all the info we need in order to create that glissando. There's a handy way to do this, because things get a little weird with messages and the multiple dollar signs. So we need to combine this into a list using the pack object. And this will just avoid a headache. It'll output 2 values, but because both of them are changing, we can just combine them like so. So we just have to tell it what kind of data to expect. And because both of these are going to be float values, we're just going to type in 0 decimal for both of them to indicate a float. Although I'm pretty sure this is always going to be an integer. It's just easier to do it like that. So whenever we send into number 1, whenever we send into number 2, boom, we've got that right there. So we will output the combined list. And I'm just going to, avoiding, if I could type, a bunch of patch cables moving and zigzagging, covering stuff up, we'll just use a send on the note information. And then over here, we'll do a receive to get the note information, just like so, into that line object. So at this point, we can output the sound and we can get a glissando. I'm going to turn that off, but you can see that we are moving to the frequency at a rate that's changing depending on how far apart the notes are. So we get that sweeping effect. But we don't have the vibrato or the filtering in order to kind of fine tune the tone. That's what we're going to add in this middle section right here. So what we can do is use an LFO in order to generate the vibrato. That's just a low frequency oscillator that is moving slower than the rate of human hearing. So what I'm going to do is I'm going to just get a copy of the envelope ramp, the pitch envelope here, and I'm just going to scale down the volume by a fair bit. So again, you could play with the mix on this if you really want to, but the vibrato is a little more of a subtle effect. Oop, this one. For what we're looking for, so we're just going to make it a much lower volume and then combine that with the output of our LFO. So another multiply tilde. Stick that there, and then our LFO, we'll stick it at 6 hertz. So by changing the speed of this LFO, you can speed up or slow down your vibrato speed. So that's a handy little tool to have there. But we have basically generated just some low volume oscillations. And if we just combine this back in with the main signal, we'll have just a single signal that we can that we can send to our oscillator that'll just have the vibrato built in. So if we start this up, you get the idea. You can hear, again, you still have the very distinct pitch that's coming through just as is, but we've just added in a little bit of vibrato on top of it. So we've got that there. All we need left is the filter, and the easiest way to do this is with a just a low-pass filter right here. So I'm going to use low res. This is another little bit of a change from the version in the book. They use a special one that as you get the book, you get a bunch of free objects with them, and they use the one that comes with the book. I'm just using low res because I don't actually have that installed in my home computer at the moment. They're all my work computer. So we're just going to take this and we're going to filter the sawtooth output. We just need to tell it what the cutoff frequency is. And if we take this signal and multiply tilde by 2, again, this is the frequency for the oscillator. If we set it up this way, we will always be able to adapt and change this with a cutoff filter for our frequency that is always an octave above the sound we're doing. So we'll still get all of the sound, no problem, but a lot of that harshness and the noise at the very top will be going away. So if we start this up, I think we've got everything, and I'm not just saying that because I've seen the final patch in the book. So at this point, this is all of the core synthesizer stuff. And this is kind of our starting template for the max coding assignment for the class that I'm teaching. And if you're, again, wanting to practice and learn Max, this could be a fun thing for you to do as well. So what you need to be able to do is take this and turn it into a usable, performable instrument, setting it up as an abstraction with your own unique variation on this sign, on this sound. So there's a few things that you're going to need. So you can save this. You can see my practice attempts up there. So I'll just call this my theremin, whatever. We'll call it that for now because we're going to change up the sound and make it distinct. But there's a few things that you can change and adjust, but you need to develop a way to do that and have inlets for your different parameters. So again, the inlet object here. So this is where you would send in the appropriate data for all the parameters that you want to change, is through the different inlets, and you can make multiple of them. Remember, if you select one in the inspector, whatever you type in the comment field will be what appears here when you hover over an inlet or outlet here to tell you what is happening. So that's a very user-friendly thing to do. But just a few things that you can change, and you can change a fair bit of stuff. This first part, you can play around and find the specifics, but you can change the speed at which the glissando happens. You can change the speed of the vibrato. You could change volume ranges if you really wanted to. The filter cutoff would be a big one, but things like that, things that are affecting the generation of the sound, that is the first part of this assignment, is just creating inlets to be able to control this. The second part of the assignment, I mentioned that we're bringing in subtractive synthesis here, is to replace this saw tooth pattern with a subtractive synthesizer that you put together. You can use any of the stuff in Max or the textbook as a resource, but you're essentially replacing this with your own subtractive synthesizer. So you can create that however you want. It can be a sub patch. It would probably be what I would recommend is just create a sub patch with a subtractive synthesis. If you want to add in sound control parameters to that, you definitely can. Just put inlets in the sub patch, but you don't have to. It can function just like the saw, where it's just outputting a single tone. But put a subtractive synthesizer here instead of the sawtooth. Have the various inlets for the control parameters, the outlet for the sound, and that's effectively it. The way we can do next is just save this as an abstraction, and what I want the class to turn in is just the abstraction by itself, as well as a max patch with the abstraction loaded and you using it. So again, just to illustrate that, I'll connect this one up to my vibrato, filter cutoff, and I don't know if the speed over here. We'll just set it up like that, and I'll make another one for the note pitch and the velocity. So this one has 5 inlets. And I'm just going to move those up there. I'm going to screen everything down. Set it like that. So if I save my theremin, I make a new version, a new max patch. If I just open up, drag and drop my theremin here, we now have this set up and we can send in the data. I just realized that I forgot the audio outlet. So this would be the first thing that gets turned in. Again, replacing this sawtooth with another synthesizer, but we'll pretend this is all we want to have edit-wise. Go for some low points on this. But here it is in another max patch. So first part would get turned in, and this would just be a simple, if I remember to type the N key, connect up K slider, maybe a few dials, I don't know. However you want to utilize this patch, like so. Yeah, so something like this, where it's just showing the patch loaded into another patch and it's usable. You don't have to use a B patcher or presentation mode for this, but I would highly recommend that you at least experiment with it once you have your actual patch done. The presentation mode stuff will be required in the next max patch thing that we do. It's not technically required here, but if I see them done really well, I may throw, like 2 or 3 bonus points at you if you want to attempt that. Nothing crazy, because that'll be part of the next assignment that you have to use those. So that's all I have for right now. What I am going to do, just as I outro here, is hop back over here and just add some comments just to label the important stuff as we go. So sound gen, replace with your own for the assignment. We have over here the filter cutoff is over here. I didn't use the Q at all. I just left it at the default there, so that could be another thing to change. I didn't have a way to control the output volume as well. Amplitude, envelope. The frequency envelope with the vibrato happening over here. And then with the previous note and the current note happening up here, and then the and I guess the reason we're calling in milliseconds is because we're generating an amount of milliseconds to use with our line object, but I just want to point out that it's, again, multiplying that distance by 20 doesn't go into milliseconds. We're just using the output value here for milliseconds. That probably makes a little more sense now that I thought about it while making the video. So yeah, we've got that there, and then the main frequency is happening over there. So and then the distance to glissando is up there. All right, so that's, again, all of the important stuff for this project. Again, everyone should be starting with the same starting point, which is here, and then you are adding your own parameter controls using the inlet and outlet, as well as creating a sub patch with saw and replacing saw with it, and that will be a subtractive synthesizer that you put together. Again, check out the recorded lessons I put in Canvas, the textbook chapter on subtractive synth. There's a lot of stuff that you can really do and play around with and get some fun noises, some slightly not traditional theremin sounds. So, like I mentioned, that's all I have for today. If you have any questions, as always, send me an email, stop by my office hours. You know the deal. I'll catch y'all the next time that I see you. Bye.